Dear students, welcome to my video class. Today I talk about one of the important concept of spectral and magnetic properties, that is called as organe diagram. What is meant by organe diagram? It is a graphical representation of the electronic transition of the metal complexes, or it is a correlation diagram. It explains the relative energies of the transitions of the metal ions. Okay. In organe diagram or use of organe diagram, we can explain some important concept. Or organe diagram used for the first point is interpretation of spin anode absorption bands. So the first point is it is used for, or by the help of organe diagram we can explain the electronic spectra of the spin alloy transitional complexes. Means what is meant by spin alloy transition? From that or from the selection rule, delta is equal to 0. That is called as spin alloy transition. It is the fundamentals of electronic spectroscopy, or the fundamentals of the electronic spectra of transition metal complexes. The delta S is equal to 0. Suppose the delta S is not equal to 0, that is called as spin forbidden transition. That is called as spin forbidden transition. Then what is meant by spin allowed and spin forbidden transition? So delta S is equal to 0 means spin allowed transition. Delta S stands for S2 minus S1. S stands for the spin quantum number, where the spin quantum number is half plus or minus half, or it's also 1. If S2 stands for the spin multiplicity of spin of excited energy level, and S1 stands for spin quantum number in ground state or ground energy state. The change in spin quantum number from ground electronic state to the excited electronic state, it must be 0. Means there is no change of its spin from ground state to the excited state, or the electrons which moves from ground state to the excited state, there is no change of its electronic level. It must be same, that is the spin allowed transition. Spin forbidden, delta S is not equal to 0. Not equal to 0 means it may be equal to 1 or 2 or 3, anyone. In that cases means at the ground state, for example, in a ground state and excited state. In a ground state, one electron in the ground energy level, it will excited to the higher energy level, and in a higher energy level only the one electron. In that case, S2 minus S1 is equal to 0. That is the spin allowed transition. Spin forbidden means suppose the ground energy level 2, or either in the fashion 1 electron, it will excited to only the 1. In that case, 1 minus 2 minus 1 is the spin delta S. In that case, spin forbidden transition. So using organe diagram, spin allowed transition show the absorption band of the transition metal complexes. Then use of, second point is use of DD, use of DD transition of octahedral as well as tetrahedral geometry. DD transition means it's the all DD transitions are spin allowed transition. Then what is meant by DD transition? DD transition means the lower D energy it will excited to the higher D energy only. Means the degenerated orbitals having its electrons in the ground energy level, it will excite it to the higher energy level. The higher energy must also at degenerated orbitals only. Means in case of octahedral, because of the use of DD transition in octahedral geometry and tetrahedral geometry. In case of octahedral geometry, the lower energy is T2G and the higher energy is EG. It will excite the electrons which moves from ground state to the highest energy level. It is also a degenerated level. So that is the DD transition. The first point and the second point is almost same because of all the DD transitions are spin allowed transition. That's why in orgel diagram or use of orgel diagram, we can interpret the electronic spectra of the transition metal complexes. These complexes are spin allowed transition, not an spin forbidden transition. What is that then? What type of system having the spin allowed transition? From the 3D degenerated level, from D1 to D9 system, D1, D2, D3, D4, D5, D6, D7, D8, D9 system, in 1 to 9 system, D5 is the D5 system is the spin forbidden transition in case of high spin complexes. That's why except D5 system, D1, D2, D3, D4, D6, D7, D8 and D9 system shows the absorption band or it shows the electronic transition from the orgel diagram. That is the second point. And the third point is the electronic transition moves from ground state to excited state, ground state to excited state should have same spin multiplicity. Having same spin multiplicity. Spin multiplicity means according to ground state calculation or spectroscopic ground state calculation, GST ground state term is equal to 2s plus 1 L of J. Here 2s plus 1 L of J, where S stands for spin quantum number and L stands for angular quantum number and J stands for orbital quantum number, where 2s plus 1 is the spin multiplicity. 2s plus 1 is the spin multiplicity. From this point, the electronic transition moves from ground energy level to the excited energy level. Should have same spin multiplicity. Means suppose in case of D2 system, the spin is half and half, that is S equal to 1. And from the formula 2s plus 1 is equal to 3. Clear? 2s plus 1 is equal to 3. Means in ground energy level, its spin multiplicity should be 3 and it will excite it to the higher energy level. In a higher energy, its spin multiplicity should be 3 only, not it changes to 2, 1 or 5, it will not will be, or 1, it will not changes. Means once it's the same spin arrow transition means its 2s plus 1 should be same only, because of if suppose in a one system s is equal to 1, 2, 3, in that cases spin multiplicity should be same in ground and energy excited energy level. And the next point is, fourth point is, it allows high spin complexes. It allows high spin complexes. Means high spin complexes means organ diagram shows the electronic spectra or electronic bands in high spin complexes only, not for low spin complexes, or it restricted to high spin complexes only, not for the low spin complexes. High spin means weak field complexes or weak field complexes means the metal approached by the ligand, and these ligands are weak ligands. That is the high spin complexes or weak field complexes. The metal approached by the strong ligands, that is called as strong field complex or low spin complexes. Why it allows only high spin complexes, not for low spin? Because of all the low spin complexes, the DD transitions showing in the organ diagram. And the organ diagram, it's always show the visible spectrum. That's why in the low spin complexes, the low spin complexes means the ligand strength should be more. That's why the energy gap should be increases. The energy gap increases means it moves on to the UV region. That's why it allows only the high spin complexes, not for the low spin complexes. Clear? The next last point is, and the last point is, fifth one point is, it is only qualitative analysis, not for quantitative analysis. Qualitative and quantitative. Qualitative means in these cases how many electronic bands are observed in a suitable complexes. That is the qualitative analysis. Quantitative analysis means number of bands and each band having its energies. We can calculate the energies of the suitable bands. That is the quantitative analysis. From the organ diagram, we can assume or we can theoretically calculate the number of electronic bands of the suitable metal complexes. That's why it is an qualitative analysis, not for the quantitative analysis. Here, these are the very important points in organ diagram. Then how to draw organ diagram? So based on the 6 rules, we can interpret or we can draw the organ diagram of D1 to D9 system. So the one by one we can discuss the rules of organ diagram. Rules of organ diagram. The first rule dn and dn plus or minus 5, dn and dn plus or minus 5 of octahedral geometry or octahedral field is same organ diagram. dn and dn plus or minus 5 of octahedral field is same organ diagram. Next one, similarly dn and dn plus or minus 5, dn and d plus or minus 5 of tetrahedral field is same organ diagram, having same organ diagram. Next, third one is dn and dn plus or minus 5 of octahedral field is reverse to that of dn and dn plus or minus 5 of tetrahedral geometry. dn and dn plus or minus 5 of tetrahedral geometry. And the fourth one is dn of octahedral geometry or octahedral field is reverse to that of d10 minus n of octahedral geometry. dn and d10 minus n is reverse energy diagram. Fifth one is dn of tetrahedral field is reverse to that of d10 minus n of tetrahedral geometry. d10 minus n of tetrahedral geometry. And the last one is dn of octahedral is same organ diagram of d10 minus n of tetrahedral geometry. dn and d10 minus n of octahedral is reverse of tetrahedral or vice versa. Suppose dn of tetrahedral geometry is same energy level diagram or same organ diagram of d10 minus n of octahedral geometry. So these are the important rules we can draw the, or with the help of these rules we can draw the organ diagram or we can construct the organ diagram. So suppose in the first rule dn and dn plus or minus 5, suppose n equal to 1, in here n equal to 1, then n plus or minus 5, either n minus 5 or n plus 5. Clear? In here n is greater than 5, the formula is n minus 5. Suppose n is less than 5, the formula is n plus 5. In here n plus or minus, suppose n is 5, 6, 7, 8, either equal or greater than 5. In that case n minus 5 will be considered, and n less than 5, 4, 3, 2, 1. In that case n plus 5 will be considered. That's why suppose n equal to 1, n equal to 1 means d1, here d1 and is reverse to that of, same of that of dn plus 5 will be considered because of n is less than 5. Means d6 system means d D1 and D6 system having same energy diagram. Clear? Having same energy diagram. Next, similarly, D1 and D6 system of tetrahedral having same energy diagram. Next, third is Dn and Dn plus or minus 5 of octahedral is reverse of Dn and Dn plus or minus 5 of tetrahedral geometry. We know that octahedral geometry is reverse of that tetrahedral geometry. Here, octahedral is reverse energy diagram or reverse crystal plate splitting of tetrahedral geometry. That's why D1 D6 system of octahedral is reverse to that of D1 D6 system of tetrahedral geometry. We consider n is equal to 1. I will give the 1 to 9. N equal to 1, 2, 3, 4, 5, 6, 7 like that. That's why. Next, fourth one is Dn of octahedral field is reverse to that of D10 minus n of octahedral geometry. Suppose D is n equal to 1, means in these cases D1 is reverse to that of D10 minus 1. D10 minus 1 is the opposite or gate diagram of D9 system, both in the octahedral geometry and tetrahedral geometry. Last one is Dn octahedral is same or gate diagram of D10 minus n, means D1 of octahedral geometry is same energy diagram of D9 of tetrahedral geometry. D9 of tetrahedral geometry. So this formula helps to draw or construct the OR gate diagram. So we can start the construction or the explain the OR gate diagram of D1 to D9 system. D1 to D9 system. At the beginning, I did a 1 to 9 system using this formula. D1, D6 system, same energy diagram. I highlight the formula from 1 to 9 system. Then D4, D9 are same energy diagram. Both octahedral geometry, tetrahedral geometry. Means D1, D6 of octahedral is same energy diagram. D1, D4, D9 of octahedral geometry having same energy diagram. Clear? Next, n equal to 1, n equal to 2, D2 system. D2 system is n equal to 2, n plus or minus n plus 5 means D7. D2, D7 of octahedral or tetrahedral geometry having same energy diagram. Next, D3 and D8, n equal to 3, n plus or n plus 5 is 8. D8 octahedral or tetrahedral geometry having same energy diagram. That is the first two rule. Next, D1 D6 system of octahedral geometry is reverse of D1 D6 system of tetrahedral geometry. Clear? D1 D6 system of tetrahedral geometry. D4 D9 system of octahedral geometry is reverse of D4 D9 system of tetrahedral geometry. Similarly, D2 D7 system is reverse to that of D3 D8 or D2 D7 of tetrahedral geometry. Next formula, Dn same energy Dn of octahedral, same energy of D10 minus n of tetrahedral geometry. Here means D1 of octahedral geometry having same energy diagram of D9 system of tetrahedral geometry. Here D1 octahedral geometry is same energy diagram in D9 of tetrahedral geometry. Similarly, D2 octahedral, D8 tetrahedral, D3 octahedral, D7 tetrahedral, D4 octahedral, D6 tetrahedral. Clear? In here D5, suppose consider n equal to 5, n plus or minus 5. If it is n minus 5, 5 minus 5 is 0, D0 system. So D0 system cannot be interpreted the electronic spectra. That's why n D5 system is spin forbidden transition in high spin complexes only, not for the low spin complexes. In low spin complexes, it allows the some transition. Orgel diagram explained only in high spin complexes, not for the low spin complexes. That's why. And the last formula is d1 and like dn is reverse of dn minus n. Means d1 octahedral geometry is reverse energy diagram of d9. Clear? D2 is reverse energy diagram of D8. D3 is reverse energy diagram or inverse crystal splitting of D7 system, like that. So based on these formula, we can explain the orgel diagram. We can explain the orgel diagram. In orgel diagram, there are namely two types of orgel diagram. The one orgel diagram contains capital D orgel diagram and second one is capital F orgel diagram, either D orgel or the F orgel diagram. What is meant by D and what is meant by F? So the capital D and F are the spectroscopic terms or spectroscopic notation, where L equal to capital L is nothing but angular quantum number is equal to 0, 1, 2, 3, 4. It indicates S, P, D, F, G, H, I, like that. So based on the L value, either the D term or the F term may explain from the D1 to D9 system. So the calculation of spectroscopic notation or the construction of D orgel diagram and F orgel diagram discussed in the